Our presentation today is about a review of artificial intelligence method for wind power forecasting. The plan that we will follow is first introduction, then wind forecasting classifications. We will focus on artificial intelligence methods, which are divided in two parts: traditional methods and the combination of meta-heuristic algorithms and classic artificial intelligence prediction method. We will sum up the previous methods and see the benefits and limitations of each one, and finally conclusion. The current time is witnessing a noticeable rise in the use of renewable energies, especially wind energy, in order to contribute to preserving the environment. A good wind forecast ensures price stability and good trading performance in the electricity markets. There are multiple methods and different classifications of wind power forecasting. Today, we will focus on the current artificial intelligence forecasting methods. For the wind power prediction methods, they are classified according to three principal categories. The first one is about wind power time prediction. They are divided in four terms: very short one, short terms, medium terms, and long terms. And secondly, we have prediction methodology. We have the physical one, statistically one, artificial intelligence methods, and the combined methods. And finally, it's according to prediction data. We can predict wind power by passing indirectly by wind speed forecasting, or just passing directly to wind power forecasting. Focusing on artificial intelligence methods and considering machine learning as a branch of artificial intelligence, various machine learning algorithms have emerged that attempt to solve non-linear problems in predictive models. Two categories are defined. On the one hand, traditional artificial intelligence methods such as commonly used artificial neural network methods, support vector machine methods, and fuzzy logic. On the other hand, we have the combination of these classic methods and meta-heuristic algorithms. As example of traditional artificial intelligence prediction methods, we have the first paper predicted wind power and wind speed using artificial neural network and RMA. For having a comparison between the two techniques for short term, the results show that the two techniques generally have good performance, better than a persistent model, but the RMA is the best. For the second paper proposed a prediction of renewable energy through machine learning and focusing on wind power prediction, four methods are compared. In this case, SVM is not the best option. It is better to combine it with the other machine learning algorithm. And finally, the third paper applied an effective fuzzy logic method to predict wind power for microgrid application in India. The results based on the proposed technique are very close to the calculated values than those obtained by the SVM model and the BPNN model. For the combination of the meta-heuristic algorithms and classic artificial intelligence prediction methods, there is a different type of meta-heuristic algorithms like evolutionary one, physics-based algorithm, human-based algorithm, and swarm-based algorithm. There is some example of algorithm. We have genetic algorithm from evolutionary algorithm. The paper presents a double-stage hierarchical genetic algorithm trained artificial neural network for short-term wind power forecasts of microgrid wind farm in China. The proposed wind energy forecasting strategy is effective. Therefore, the obtained numerical results confirm the effectiveness of the proposed strategy. For the PSO from swarm-based algorithm, a wind power forecasting method combining PSO and BP neural network is proposed. So the main global goal of using this technique is to obtain the initial weight of BPNN by PSO algorithm in order to overcome the difficulties by falling into local optimal solution and improving the conversion speed of the predictive model. The results of the proposed model and other techniques are compared, and the results show that the PSO-BP neural network is better. So for GSA, from physically based algorithm, wind power prediction model based on the GSA optimized JLU neural network is proposed. So the predictive model parameters are optimized by the GSA with strong global optimization ability, which is effectively improves the prediction accuracy of the model. And finally, we have harmony search from human-based algorithm. The paper proposed a wind power forecasting approach based on LNF model composed of the SVM was employed as the forecast engine and harmony search as algorithm for optimization. So the comparison to several other methods confirms the superior performance of the proposed method. There is the benefits and limitations of each technique. We have for artificial neural network, they are easy to understand and to apply, but they need to be fed with a huge amount of data. For SVM, it is capable to solving binary classification problems, but it needs complex calculations. And for Fuzzy Logic, it's easy to understand, to use, but it's not often used by researchers. For the meta-heuristic algorithm, for firstly evolutionary based algorithm, it's easy to implement, but it has a slow conversion speed and a large computational time. For physical based algorithm, it has a high accuracy in the results, but it's not often used. Also, the same thing for human based algorithm. And finally, swarm based algorithm, the commonly used one, it has a high performance, but it depends to the initial parameters. So as a conclusion, the traditional artificial methods can usually give an acceptable results, but using the combination between these classic methods and meta-heuristic algorithms provide high performance as shown previously. In each category, there is some methods commonly used like BPNN and LSVM for classic IA methods, and we have also PSO JA for the combined meta-heuristic and classic artificial intelligence methods. For more accuracy, we can combine different meta-heuristic algorithms with standard artificial intelligence prediction methods in order to benefit of the advantages of each one. Thank you for your attention.